All right, so the first problem, if you have linear growth and exponential growth where they're both increasing, it's just a matter of time before that exponential growth is going to pass it, even if it has a higher initial value and a large slope on the linear growth. The exponential is going to pass it in the long run. You guys did well on that. When you have, doesn't matter the investment amount or for how long, if you're compounding more often with the same annual interest rate, you're going to get more interest. So you want to compound monthly rather than quarterly on this for the second one. And for the third one, the effective interest rate, let's see. Yeah, because you're compounding monthly, you get more interest on your interest. So you're going to get, let's see, the effective interest rate will be more than 5% because you're getting interest on your interest rate. You could also use the formula and actually calculate it. Some of you did this, 1.05 divided by 12, and did that to the 12th power. And I think this came up to be 1.05116, so that you'd have an effective annual interest rate of 5.116%, if I remember right. So it's not a big difference, but it's going to be a little bit higher the more you compound on that. For problem 4, the general form of exponential growth, this would be when it is not continuous. And if you look at it, it just says 13% per year, so this would not be continuous. And you guys did a nice job of recognizing that it is going down, so that would be a negative, and the growth factor then would be 0.87 or 87% each year of what you had the prior year. So it would be the cost would be the initial value, the $230, and then the 0.87 to the t power on there. And problem 5 is similar, but note it's a continuous rate. So that means we will use the e to the power of kt with continuous growth rate. And so here this would be a negative 0.09 t e to the negative 0.09 t times the initial value. And so I think this was worth 2 points. I think I took off, if you did it correctly, for just a growth rate of 9%, not accounting for the continuous nature on that. And then problem 6, growing in size. So that would be P2 and P4, where they have growth factors bigger than 1. All right, any questions on the first page?